Hello everybody, welcome to week 2 of Math 0900. We are now going to begin working in chapter 1 starting with lesson 1. By the end of this lesson we are going to be able to identify the different types of numbers in the real number system, use real numbers to add in real life situations, add real numbers with the same sign, add real numbers with different signs, and then lastly, use the addition property for real numbers. Now, we do have some terms that we need to know in this section, and there are truly a lot of vocabulary words that you need to make sure that you understand here. And I am going to start by adding one vocabulary word to this list because I think that it's important that we know this word, and it's not in your textbook. It is the group of numbers known as the natural numbers. I'm sorry that my U got a little bit blurred together with my R there. So we have the group of the natural numbers. This is the group of numbers that you first learned to work with way back when you were a baby or a toddler. The natural numbers are the group of numbers that you learn to count with. So they are the numbers 1, 2, 3, 4, etc. When you said to your mother when you were a child, "Hey mommy, look, I counted this group of pens. I have 1, 2, 3, 4 pens." You were using the natural numbers. Then as you got older, you probably started to understand that sometimes you had nothing. And there is a number that represents the quantity nothing. That's where the group of whole numbers comes in. The group of whole numbers is the group of numbers 0, 1, 2, 3, 4, etc. And the difference there is that we include that value of 0. So the group of whole numbers is 0 plus all of the natural numbers. Whole numbers do not have any fractional parts, and they do not contain any decimal values. Moving on, we get to the group of numbers called integers. Integers contain all of the whole numbers and all of the natural numbers, but they also contain all of the opposites of the whole numbers. So by definition, an integer is a whole number and its opposite. So those are the numbers like -3, -2, -1, 0, 1, 2, 3, etc. So I've introduced you to the basic numbers that make up what's known as the real number system, right here, the real number system. All of the group of numbers that I've talked to you about so far are part of the real numbers. But you may notice that they don't contain or represent any of the fractions or decimals that exist in our life, because it sure would be nice if all we had to work with were natural numbers or integers or whole numbers, right? Because we like numbers like that are just nice and perfect with no fractions or decimals. But unfortunately, we do have to use numbers that contain fractional pieces. So let's start talking for a minute about the difference between the rational and irrational numbers. If you want to think about the real number system as a tree here, you start with the group of real numbers, and pretty much every number that you're going to work with is a real number. There's one other group of numbers that it could be, and that is the imaginary numbers, but we're not going to talk about them right now. You're going to take all of your real numbers and they're going to be able to split into two possible ways. They're either going to be a rational number or they are going to be an irrational number. Now, what is the difference between the two, you may ask? A rational number is any number in the real number system that can be written as a fraction. Any number that can be written as a fraction. We can take a whole number and write it as a fraction, If we have the number 3, we can make it 3 over 1. If we have the number 2, we can make it 2 over 1. Negative 5 can be negative 5 over 1. Those can all be written as a fraction. So if your number can be written as a fraction, it is automatically a rational number. Other types of numbers that are rational are decimals that will either, and this is very important, terminate, meaning that the decimal stops, like 0.8, 0.25, 0.3. The decimal comes to an end. Or decimals that repeat, like 0.33333 forever, 0.6666666 forever, 0.125, 125, 125. There's a pattern to that decimal. Those are also rational. Okay? Then you have this group of numbers called the irrational numbers. And you think, well, what could those possibly be? Those are numbers that cannot be written like a fraction, such as the number pi. It's irrational because if we think about the number pi and think about it when it's in its decimal form, we have 3.14159, and then a bunch of numbers that are going to go on in this crazy extended form. Those numbers will never terminate. They will never repeat themselves. They just keep going on and on and on and on and on and on forever with no pattern. If you think about it, that's a little bit crazy and it's a little bit irrational, right? That's how I remember what an irrational number is. So it cannot be written as a fraction, and when it's in its decimal form, it will never terminate, it will never repeat. If you have the square root of a number that is not a perfect square, which we will talk about this week as well, such as the square root of 5, let's talk about that. If you try to put that in decimal form, since it is not a perfect square, you will get some kind of crazy decimal that will never ever end. It's 2.236067977, going to go on and on and on and on forever with no pattern. That is an irrational number. Okay, so that is the introduction that you need in order to be able to identify the different types of numbers. What I would like you to do right now is pause the recording and fill in this chart based upon the definitions that I have given you for our numbers. I have left off natural and whole numbers from this chart because if it is a natural and a whole number, it will automatically be an integer. So that's what I want you to remember those numbers as being, is integers, because it's very important that you learn that vocabulary word because integers are very important to algebra. So please pause this recording and fill in that chart. Okay, by now you should have completed the chart and you should have found that the number 5 is an integer, it is rational, and it is also real. Negative 1/3 is not an integer because it's not a whole number. It has a fractional component, but it is rational and it is also real. The number 2.85 is not an integer because it has a decimal component, but since that decimal terminates, it's rational and it's also real. The square root of 2. The 2 is not a perfect square, so if you were to evaluate the square root of 2, you would get some crazy decimal that goes on and on and on forever with no pattern. It's irrational, it's a crazy number, but it's also real, so we'll keep it. And then lastly, we have the number 0.77777. That's repeating. That's rational and real. Hopefully you were able to fill in that chart. If you have any questions about what those words are, just let me know. Okay. Now, I do want to point out to you that all real numbers have a place on a number line, and they do include the set of positive numbers, negative numbers, and zero. Okay, so that whole real number system that we're talking about, if you want to think about a number line with zero in the middle, okay, and you have your 1, your 2, your 3, every single number that could fall somewhere on this number line, starting with 0, going all the way to infinity and negative infinity, okay, is a real number. Okay, it exists in our world. We can use it. We can work with it. It is a real number. All right. Now we're going to learn how to use real numbers in real life situations. Now, real numbers are used to represent real situations. And often, keywords tell us exactly what we need to know about the problems that we are trying to set up. EI, word problems, everybody's favorite type of problem, right? But it's very important that you understand how to set up these problems, and identifying the keywords is going to be important to you. So what I want is for you to use a real number to represent each of the following situations. I'll help you out with letter A, and then I want you to do B and D without me, and then we'll come back together to represent them. Letter A says that the temperature of 128.6 degrees Fahrenheit below zero is recorded at Vostok, Antarctica. Your key word here is below zero. Since this is indicating that it's below zero, think about that number line. It's going to be to the left of zero, and that is going to be a negative value. So as we are turning this into a real number, we should be doing negative 128.6. Please pause the recording, do B, C, and D on your own, and come play it again as soon as you're finished. Okay, by now you should have done B, C, and D on your own, and you should have had positive 29,064 for B. For C, we should have had positive 10.24. And lastly, for D, we should have had negative 328 feet. I am going to go ahead and stop the recording right here because I don't want it to time out on me. And we will pick up with the next part of the recording in just a minute.